This is 6-1 integer exponents. Anytime you have a 0 exponent, the result is 1. So like x to the 0 is 1. 4 to the 0 is 1. And this actually makes sense because if you think about like 4 to the third is 64. It means 4 times 4 times 4. 4 squared is 16. 4 to the first is 4. And if you look, the pattern each time is dividing by 4. So if I divide by 4 again, 4 divided by 4, I get 1. And if I drop my exponent down 1 each time, I would end up at 4 to the 0. So anything to the 0 power is 1. And then we get into exponents as well. So if I drop this down 1 more and I drop to 4 to the negative 1, you'll notice that if I divide by 4 here, I can just write it as a fraction, 1/4. And 4 to the negative second, if I divide by 4, it would be 1/16. But what's really happening is it's 1 over 4 squared, the positive. If you drop that down into the denominator, the negative 2 power becomes positive 2. So 4 to the negative 3 is 1 over 4 to the positive 3, which equals 1 over 64. Some of these exponent rules that you're seeing here are carryover from pre-algebra, so there'll be that separate video on exponent rules posted. Example 1 says the diameter for the Model A Ford piston could vary by at most 10 to the third inches. Simplify the expression. We'll 10 to the negative third, sorry. 10 to the negative third. We don't want that negative exponent, so we can drop this into the denominator, and it becomes 10 to the positive third. And 1 over 10 to the third would be 1/1000. So for example 2a, 2 to the negative third, that's going to be 1 over 2 to the third, and then we're going to calculate that. 1 over 2 to the third means 1 over 2 times 2, which is 1 over 8. 5 to the 0 power. 5 to the 0 power, anything to the 0 is 1, so I don't have to do much there. Negative 3 to the negative fourth, so what's happening is it's 1 over the negative 3 remains the same. It's the power that becomes positive. So 1 over negative 3 times negative 3 times negative 3 times negative 3, which is going to be 1 over 9 times 9 is 81. And it's positive because there's an even amount of negatives there. And then for this other one, it's 1 over negative 3 to the fourth power. And since there's no parentheses here, I actually am going to do the exponent first. So the negative stays out by itself. It's like a negative 1 times 3 to the fourth. So I'll take care of that in a second. So I'm going to be doing the 3 times 3 times 3 times 3. And so this results in 1 over negative 81. And that has something to do with PEMDAS, where you do exponents first. You do this exponent and then put back the negative. Here with the parentheses, they stay grouped together. That's why all of these remain actual negative 3's. Okay, when we replace variables, we need to do so with parentheses. This is important, especially involving exponents. So I need to get rid of that negative 1, so I put that in the denominator. It becomes positive 1 for the exponent. So 1 over 2 to the first is just 1/2. For this next one, 8 to the 0, I don't even need to look at that if you don't want to, because it's just 1. It's 1 times this stuff, so it's going to be 1. And b to the negative third, that's negative 2 to the negative third. So 1 times negative 2 to the negative third. I don't need to worry about the 1 times because it's not changing the answer. Anything times 1 is itself. And I need to get rid of that negative exponent, so let's drop that to the bottom. So it becomes a positive 3. And now I can calculate 1 over negative 2 times negative 2 times negative 2, which is 1 over negative 8, or negative 1/8. And I'll show you how to do some of these in your calculator as well. It's just that you have to remember the parentheses or your calculator is going to mark it wrong. Okay, to simplify each expression, with variables here, what we do is we're just going to take what's negative and drop it down to the opposite of the fraction. So if it's in the numerator, it's going to go to the denominator and vice versa. So this is going to become 3 over y squared. This k to the negative fourth is going to move up to the numerator so that it can become positive, k to the fourth. Okay, the negative 3 here has to drop down. The x to the negative 3 has to go down. The a to the 0 is 1, so I don't need that. And so nothing is left up top, but I have to leave something in the numerator. So I'm going to put a 1. It's 1 over x to the third, y to the fifth. I could have done y to the fifth, x to the third, but it's more common that we keep things in alphabetical order.